What if we could better monitor indicators of sea ice breakoff? Hello, my name is Ada Lowen, and I'm a PhD student at Carleton University. I'm working with a team of scientists at Carleton University, the Canadian Ice Service, and with partners at Smart Ice to try to understand what happens to sea ice before big breakup events like this, or smaller breakout events like this, occur at the flow edge to try to get a better sense of when these events might happen in the future. In this video, we'd like to share with you, the community of Ikpiarjuk, some of the things that we've learned so far about the ice in Admiralty Inlet and what happens to it before it breaks up. We know how important traveling to the flow edge is for Inuit in Ikpiarjuk, and although we don't get to have the chance of traveling on the ice as much as you do, we're really interested in putting together our knowledge and yours to better understand the ice and to make travel to the flow edge safer. Before we get into what we've learned so far, I'd like to introduce a few of our team members. At Carleton University, we have Derek Mueller, who has been studying ice in polar regions for over 20 years. Greg Crocker, who has experience conducting sea ice programs for over 40 years, as well as Calder Patterson, Joshua Turner, and myself, who have more recently begun studying sea ice. We also have Adrian Tivey, an ice specialist with the Canadian Ice Service, Trevor Bell, founding director of Smart Ice, and Andrew Ariak, Kikikatalik North, regional operations lead with Smart Ice in Pond Inlet. This research started in 2019. You may have met a few of us when we visited the community in May of 2019. Smart Ice also conducted some workshops with elders and hunters in the community to help us understand what you already know about breakoff events and what questions we can try to help answer. Although we haven't been able to come to Ikpiarjuk in 2020 or 2021 to experience the ice for ourselves, we have been able to learn a few things that we would like to share with you. We would love to hear if you have any comments or suggestions for us as we continue with this research. We looked at pictures of ice in Admiralty Inlet that were taken by satellites from space every day in the spring of each year from 2000 to 2020. That's 20 years of satellite images. Some of these images have clouds in them, which makes the ice hard to see. But some images allow us to see the ice really clearly. These images allowed us to see when both large breakoff events happened, or when smaller pieces of ice broke off from the flow edge. By looking at all these images, and from what we heard at the workshops, we learned that breakoff is generally happening earlier than it used to. On the graph shown here, we can see when large breakoff events happened each year from 2000 to 2020. From 2000 to 2012, large breakoff events generally happened after Canada Day. There was only 1 year before 2012 that a large breakoff event happened before Canada Day, and that was in 2006. But since 2012, these breakoff events have been more likely to occur before Canada Day. We also counted the number of both big and small breakoff events that happened each year from the satellite images. We were able to see that there were twice as many breakoff events after 2012 as there were before 2012. Have you noticed any changes in the ice or the weather that might explain the difference in breakoffs before and after 2012? When we were able to come to Ikpiarjuk in 2019, we put out some instruments to help us understand what the winds and ocean currents were like in Admiralty Inlet, and how the winds and currents affect breakup. First, we found that the wind speed and direction that we measured within Admiralty Inlet could be very different from the wind speed and direction that were measured at the Arctic Bay Airport, or what you might see on the weather app windy.com. This can make it hard to use information from the Arctic Bay Airport or windy.com to understand when and why breakoff happen. Second, we also measured the ocean currents in one location in Admiralty Inlet and found that they are not very strong, but are affected a lot by the tides. In the future, we'd like to learn more about what the currents are like in different parts of Admiralty Inlet. We also learned that it doesn't take very strong winds or currents to cause the ice to move out of Admiralty Inlet. Instead, We learned from the workshops that other factors play important roles in allowing the ice to break off and drift out of Admiralty Inlet. For example, cracks or leads that form across the inlet in similar locations each year, cracks that you've probably had the experience of crossing over, are important for the location of breakoffs. Another factor is the opening of leads along both shorelines of Admiralty Inlet. By placing cameras that automatically took pictures every 15 minutes from the shoreline, we were able to create these interesting time-lapse videos to record what happened to the ice near the shore before breakoff occurred. These videos showed us how the ice melted near the shore and started to move around before breakoff happened. Also, if you look closely at the video, you can see how the ice moves up and down as the tide comes in and out, and the sea rises and falls. We heard in the workshops that ice moves to the south near Sujuktulik after breakup, but moves to the north at locations north of Sujuktulik after breakup, which was another interesting thing that we were able to see in these videos. Despite all of the things that we've learned so far about ice breakoff, there is still much more that we don't understand very well. Some questions that we would like to explore include, what are the signs or indicators that would tell us when breakoff is likely to happen? For example, is it the amount of snow on the ice? Is it the air temperature, or wind, or ocean currents? Or some combination of these factors? We're not sure yet. Some other things that we're trying to understand are, how does the opening of a shore lead affect breakoff? How does the ice near the shore change before breakoff occurs? How can we monitor what happens to the ice near the shoreline? We're also interested in understanding more about the cracks or leads that cross Admiralty Inlet. Do they form each year, or do they change their location from year to year? Do they form at the same time each year? What causes these cracks to form? These are all questions that we're trying to answer that might help us better understand when breakoff might happen and provide information to the community to help make traveling near the flow edge a little bit safer. A few of us are hoping to come visit the community again soon, when we can talk about all of these questions in person and collect more data. In the meantime, if you have any thoughts, questions, or concerns about this project, please let us know. We'd also like to thank all the people in the community who have helped us so far in this research. Everyone who helped us in the field, the Hunters and Trappers Organization, the Guardians, Arctic Bay Adventures, and so many others. Kuyanami.